Hello everyone. Today we're going to introduce the case of self-driving trucks in the logistics industry. Nowadays, 70% of American freight is carried by trucks across the US highways, thus generating billions in revenue each year. However, this industry is currently facing a lot of challenges. In the following presentation, we're going to demonstrate how AI technology can help to resolve many of these inefficiencies and improve processes for large freight companies. We'll start this presentation by doing an overview of the technology, and then we'll move on to the potential benefits and risk, the user cases, the future considerations, and the recommendation.
We will use this model to explain what artificial intelligence is and how it differentiates from the human and computer intelligence. Traditional computers are only able to execute simple and pre-programmed tasks by understanding the relation between data. That is, they put data in relations by following a predetermined pattern associated with clear and predictable outcomes. Unlike traditional computer, artificial intelligence is able to identify patterns by itself through its own experience without a need for human intervention. In the future, AI will try to replicate the human brain and to develop the capability of reasoning and to experience emotions. Now that we've identified what AI was and how it's different from a traditional computer, let's look at its characteristics. The first one, and the most important one, is that it's able to resolve complex problems. The AI is able to draw upon its previous experiences to identify patterns and logic rather than just applying them. This way, unlike a traditional computer, it won't stop working when stopped with a complex problem without a clear pre-established answer, but will be able to adapt to it. The second characteristic of AI is that it's composed of three driving factors. The first one is its algorithm, which is a process or the set of rules created by humans behind the AI logic. The second factor is AI advanced hardware and computing power required to treat the massive amount of data that the AI is constantly being exposed to and analyzing. Finally, an AI is as good as its data, as this is the source of its problem-solving skills. The data part is often considered as the most valuable part of the AI and will make the difference between a mediocre and an excellent AI. This leads us to the third characteristic from AI. It learns from experience. A traditional computer program is almost set in stone. That is, once the program has been created, the algorithm will not change throughout its usage. On the other hand, AI learns from its mistake and the millions of data it has been exposed to identify new patterns, create new solutions, and new ways to respond to a problem. The AI constantly and autonomously improves its algorithm through data. This is extremely useful in the case of self-driving cars, as the more people will be using them, the more data will be collected, and the more perfect the self-driving cars will be. Finally, AI has a unique feature called the black box, which is its capacity to provide us with some unique and almost peculiar solution that we're not able to explain. In other words, AI is able to reach conclusion from a specific logic that is so advanced and complicated that even the humans who designed the AI cannot understand. Now that we've understood the basis of AI, we'll look more closely at its application within cars. A car automation is usually based on a 5-level scale divided into two categories. Level 0 representing cars with no autonomous features. The assistive category represents the car with features that facilitate the driving experience for the conductor, but that still require humans to actively drive. In this category, Level 1 represents cars in which one automated feature is incorporated, such as automatic braking or parking assistance, while Level 2 represents cars with 2 or more features. The second category of automation represents cars that are able to drive without human assistance. Currently, the most advanced cars are at Level 3 and are able to drive themselves but still need to be supervised. At Level 4, cars are able to drive without supervision only in certain environments. Finally, at Level 5, cars are fully automated and never need any human intervention. It is generally accepted that 5 major components exist and permit self-driving cars to drive without human intervention. These components are divided into two categories: environment perception and path planning and driving. Environment perception represents how the car makes sense of the world surrounding it. That is, how the car obtains information about its surrounding, what they are, where they are, and where the car is within this world. The very first step of this process is computer vision. During this phase, the cameras and all the sensors, such as lasers, radars, and sonars, located on the car, gather as much information as possible to create a comprehensive map of the car's environment. The sensors identify other vehicles, lanes on the road, obstacles, human being, traffic sign, as well as any other information that the car will need. The second step is called sensor fusion and refers to the compilation and the combination of all the data gathered by the sensors. This is extremely relevant as it permits to avoid repetition of information. For instance, 3 different cameras might each detect a single individual crossing the road in front of the car. Without a sensor fusion, this information would be comprehended by the AI as 3 different individuals crossing the road, while with sensor fusion, the AI understands that these 3 information are the same and that there is only one person crossing. The last step is called localization. This phase represents the continuous location of the car within the environment by the onboard system. Due to the necessity to be extremely accurate during each maneuver, GPS cannot be relied upon as they only accurate up to 1 to 2 meters, which could translate on the road as the car driving on the sidewalk, while on the other hand, the existing onboard system are accurate up to 1 to 2 centimeters at all times. Now that the environment and the location of the car have clearly been identified, the AI will use this information to plan the optimal path and to drive. Path planning, as its name indicates, represents the phase in which the AI plans an optimal trajectory for the car to proceed. First, the prediction model, which relies on neural network, uses the experience acquired through the huge amount of data it has been exposed to estimate what other cars, pedestrians, and other obstacles will do. Once this prediction is done, an optimal path that will respect speed limit, distance with other cars, regulation, as well as many other variables will be selected among thousands of other possibilities. Once the AI decided on a course of action, it will select the appropriate speed, turning angle, and timing to make sure that the maneuver will be done safely and as smooth as possible for the passengers. Path planning probably represents the most difficult action that the AI must accomplish, as it requires a huge amount of training data into the algorithm before the car is able to respond to all the situations that one can experience on the road. The last part is the actual driving. This is the phase in which the AI takes control of the steering wheel, accelerator, and all the other needed intermediaries to properly execute the trajectory. This is separated from path planning as there is a considerable difference between planning to do something and actually doing it.
Now that we have learned how the technology of self-driving truck works, we would like to present some potential benefits and some risks that its application might bring to the logistics industry. If we start by looking at the benefits, the first one is increased safety. Currently, 90% of truck accidents are caused by human error, and automated trucks would have the potential to effectively eliminate this risk. In addition, high cost efficiencies are expected. This automation will allow companies to save substantial amounts on the cost of fuel, on the labor costs associated with the drivers, and on insurance premiums. As the trucks will be self-driving, the company will not need to consider the workload and the hours of the driver. Indeed, a 24/7 active operation with an advanced delivery network will enable a strong competitive advantage and again lead to considerable cost savings. Additionally, the use of automated trucks would create other benefits such as generating less pollution due to an efficient driving, and also would permit new career paths for truck drivers who could learn new sets of skills. However, all of these potential benefits also bring some risks that needs to be considered. Firstly, the technology will increase the switching costs, more specifically with the purchase of new trucks. Additionally, another risk is the growth dependence on third parties such as truck manufacturers. Here, a good cooperation will determine the success or the failure of the company. Another risk is the possibility of hacking the automated trucks. Because of the software they operate on, self-driving trucks are vulnerable to hackers and other types of criminals. Many of the truck drivers have been operating for decades, and consequently, it might lead to resistance of the workforce to adapt to new careers within the logistics industry. Also, the necessary skills will change, and therefore a shortage of qualified workers in the short run can exist if not well prepared. Finally, the public perception of self-driving trucks on the road can impact the implementation of this technology in the logistics industry. Some of the mentioned benefits have already been observed within the company Embark. It is a semi-automated truck startup that built a computerized autopilot system that does not require the control of a driver, only its surveillance. The semi-automation means that there is still a driver at all times present in the truck, but he does not operate the vehicle on highways. The driver is only required on maneuvers outside from the highway. Frigidaire partnered up to deliver its refrigerators from Texas to California. Refrigerators were successfully transported 650 miles, out of which 306 miles in automated mode, with the driver only taking over control for mandatory roads. The semi-automation on highways already resulted in cost savings and efficiencies by driving in a very constant and efficient manner. Several trips have been completed through 4 states using Embark automated trucks. In 2016, Embark gained state approval to drive in Texas, New Mexico, Arizona, and California to coordinate testing activity. However, Embark is still limited to use only semi-automation and to have one driver present at all times. The second user case is about self-driving trucks, which are already used in the mining industry. One example is BHP Jimblebar Mine, where 50% of operations is fully managed by automated trucks. By the end of 2018, it is planned to move completely to driverless trucks. The fleet of self-driving trucks reduce haulage costs by about 20%, increase truck utilization, and reduce potential safety incidents. Costs were reduced by increasing the predictability and productivity of haulage operations, which collected and analyzed data. Track paths, ramps, and load zones were optimized in order to improve the performance of the truck within every component of the transportation cycle. Trucks utilization was increased by unnamed trucks that are able to streamline the rigorous procedures mining can take, running 24 hours a day, 7 days a week, with no breaks or shift changes. Operations became more predictable for mining companies, helping to remove the human error and fatigue possibility. In addition, automation in the mining industry was especially an important step towards more safety of people that would normally work in dangerous environments. The current workforce was upscaled and was offered different careers direction internally. However, the use of self-driving trucks was only possible in this environment, as the automated vehicles drive in areas where no humans are allowed. These trucks drive along controlled and closed mining sites and do not access public roads or move out from the mining sites. Which brings us to the overall future consideration of this technology when applied to the logistics industry. It is also important to note that self-driving cars come with a number of non-technologically related problems and challenges. On a legal standpoint, automated cars are still in their development phase and are not authorized to drive in most countries. Even in countries allowing them, like the United States, they are only allowed in 4 out of 50 states. Secondly, considering the responsibility in case of accidents on the road is always placed on the driver, laws will greatly vary from their current state. It is impossible to determine what lawmakers will decide and who would be responsible in case of an incident. Finally, there is currently no existing insurance for self-driving cars, and insurance companies have not given enough information regarding their change in policies. Another broader problems exist and are generally associated with self-driving cars is a trolley dilemma. How will the car react in life and death situation, and who will be chosen to die instead of the other person? Finally, other problems like security concerns due to potential hacks, the public perception of self-driving cars, as well as the workforce transition that this new technology will create, are among the numerous challenges associated with automated cars that companies will need to think about and how they want to approach this new technology. Despite the current technical, regulatory, and societal hurdles to the uptake of driverless vehicles, the presented user case have already indicated a broad willingness to deploy autonomous technology in this industry. Therefore, we have 3 recommendations for the business. Firstly, we suggest to start with specific user case within the organization and to keep opportunity costs in mind. Self-driving trucks are particularly promising in the logistics industry, but the technology is still emerging. We would like to emphasize the urge to invest and dedicate human resources to analyze the potential opportunities at hand. Secondly, we would recommend to work closely with authorities to facilitate the regulation adaptation. The current legal framework is not adapted to the existence of self-driving trucks on public roads. Consequently, the implementation of autonomous trucks won't be driven by technological advances, but rather by authorities which enforce the laws. Finally, one should consider to better understand the emerging partner ecosystem. As this organization will not produce their own self-driving trucks, it is of high importance to contact truck suppliers and to start establishing strong relationships. As such, the question is no longer if, but rather when, autonomous vehicles will drive onto our streets and highways. As the speed of adoption increases, particularly in the ideal working environment of the logistics industry, it is clear that logistics services providers can have a key role to play.